This is Mrs. Moret with a review of special right triangles. The special right triangles we're talking about are these two here. This is called a 45, 45, 90 triangle. And the reason why is it's got two angles that are 45 degrees and the third angle is 90 degrees. Same idea, this is called a 30, 60, 90 degree triangle. And again, it's got a 30-degree angle, a 60-degree angle, and a 90-degree angle. So in the 45, 45, 90 triangle, it's an isosceles right triangle, meaning that those two sides are the same. And in a 30, 60, 90 degree triangle, we don't actually have that same relationship. But because there are some relationships that exist between the sides in both of these types of triangles, it's worth us spending some time on because you can use those kind of like shortcuts to figure some things out. So let's look at the 45, 45, 90 degree right triangle. So again, we just said that this side and this side, they're congruent to each other. So if we say that this side is x, then this side is also equal to x. Now, it's not really obvious then what the value of the hypotenuse would be, but remember the Pythagorean theorem. The Pythagorean theorem says a squared plus b squared is equal to c squared. Now, a and b are both legs, and c is the hypotenuse. So if we say, okay, so this is c, what I know is that c squared is equal to actually x squared plus x squared, since a and b are both the same in this example. So x squared plus x squared, or c squared is equal to 2x squared. So remembering that we've done a lot of work this year in solving equations somewhat similar to this, that we can use square root to solve this. So I'm going to square root both sides of this equation, and that gives me c is equal to the square root of 2x squared. Now, the square root of 2x squared, well, that's equal to the square root of 2 times the square root of x squared. And since the square root of x squared is just equal to x, I can simplify this to x root 2. So in a 45, 45, 90 degree triangle, the relationship between the three sides is if each of the legs is x, then the hypotenuse is x times the square root of 2. And we're going to go ahead and do some examples using this. Here's an example where I have a 45-degree angle here, a right angle here. So the first thing I can tell is that this angle here is also going to be 45 degrees. So the first thing I know is x is equal to 45 degrees. Okay, now this side that has the 10 on it, that's one of the legs. So if this truly is a 45, 45, 90 degree triangle, then I don't really need to do much work to find the value of y because it's going to be the same as the other legs since those are congruent. So y is also equal to 10. And then finally, the side with the z is equal to 10 root 2. So that was a pretty simple example. But how can I find if I'm going to go ahead and make myself a right triangle here? And I can do this by scooting that all the way over. So now I have this right triangle. And let's say that in this right triangle, well, here's a right angle. This is a 45-degree angle. So then this also has to be 45 degrees. Let's say the only thing I know about this right triangle is the length of the hypotenuse. So I'm just going to say the hypotenuse is equal to, has a side length of 15. So how can I find then the legs? Well, if I know that these are going to be the same, then they're both equal to x. And in comparison to the x, I know that the 15 is equal to x root 2 from the relationships I just found. So now notice this is actually an equation. So if 15 is equal to x times the square root of 2, then I can solve for x by dividing by the square root of 2 on both sides. And this looks great, only it just doesn't, it's not in the form that we typically see. We typically don't put irrational numbers in the denominator of a fraction. So we do this little process called rationalizing the denominator. And so since the square root of 2 is an irrational number, I'm going to rationalize the denominator by multiplying by the square root of 2 over the square root of 2. And what that equals essentially is just 1. So I'm not changing the value of my answer. I'm just putting it into a different form that's acceptable. So 15 times the square root of 2 is 15 root 2. And the square root of 2 times the square root of 2 is the square root of 4. And so I've just got one more step to simplify. I've got 15 root 2 over the square root of 4, which is equal to 2. Now we're going to look at 30, 60, 90-degree right triangles. So the proof for this right triangle involves using the sine of this 30-degree angle. So if I look at using Desmos and changing the mode to degrees, I want to know what is the sine of 30 degrees? So the sine of 30 degrees oops, there we go. The sine of 30 degrees is 0 0.5. How is that going to be helpful? If I know that the sine of 30 degrees is equal to 0 0.5. Well, I want to think about that 0 0.5 as a fraction. So 0 0.5 as a fraction is equal to 1/2. And so thinking back to the trig ratios, remember that sine is equal to the opposite leg over the hypotenuse. So the leg opposite the 30-degree angle is here, and then the hypotenuse is opposite the 90-degree angle. So if this is equal to 1/2, then what that tells me is that if this is a 1, then this is a 2. So that short leg in a 30, 60, 90-degree right triangle is actually half the hypotenuse. But then what is this down here? So we're going to go ahead and name this x. And actually, to find the exact value of that side, we're going to once again use the Pythagorean theorem. So I'm going to draw a line here because now we're going to be talking about finding x. So I know that the legs squared added together is equal to the hypotenuse squared. So what that tells me here is 1 squared plus x squared is equal to 2 squared, or 1 plus x squared is equal to 4. And so move the 1 over, and we get x squared is equal to 4 minus 1 is 3. So x itself is equal to the square root of 3.